Welcome to Minute Profinet. Today I will be explaining the differences between the two most popular automation protocols, Profibus and Profinet. Before we get started, a quick introduction. My name is Michael Bown. I am part of PI North America, a non-profit member-supported organization. We aim to promote and educate the public on industrial automation and networking technologies. If you'd like to stay up to date and watch more of our videos, please subscribe to our channel. But for now, let's go to the whiteboard for a complete Profibus versus Profinet comparison.
So, what is the difference between Profibus and Profinet? In short, Profibus is a classic serial field bus, and Profinet is an industrial Ethernet protocol. Profibus and Profinet are both IEC standards created by the same organization, Profibus and Profinet International. Everything started with Profibus, introduced in 1989 and grew rapidly in the 90s. Then, as the industry shifted from field buses to industrial Ethernet, PI developed Profinet, which became available in the early 2000s and has grown rapidly ever since. Because of their common source, Profibus and Profinet do share some similarities, but generally they're very different. Just by visually observing and comparing their networks, you can spot some key differences. Profibus networks are generally characterized by purple, single-pair RS-485 cabling, and those cables use the common DB9 or M12 connectors. Profinet networks, on the other hand, typically use green, industrially graded Ethernet cables. For Profinet networks, the most common connector type is RJ45, but M12 connectors are also used in high exposure environments and BFOCs for fiber optic applications. Now let's cover a more in-depth comparison. Profibus is based on RS-485, which is a common serial communication method. In a Profibus network, you have Profibus masters and Profibus slaves. The master can be, for example, a PLC, PAC, or DCS. Profibus slaves can be a wide array of devices: drives, motors, IOs, sensors, field devices, robots, actuators, and more. Profibus has two flavors, Profibus DP and Profibus PA. The general principle of Profibus is collecting multiple inputs and outputs from the field into a local IO device and then transferring the data through just one cable to the master. This approach saves costs by the omission of additional hardware and cabling. Also, it saves engineering time as it streamlines network installation, maintenance, and troubleshooting. Profibus PA is the same Profibus DP protocol but based on a different physical layer, MBP. Profibus PA is proven for use in explosive areas where intrinsic safety is required. When installing a Profibus network, users link each device to the next in a process commonly referred to as daisy chaining, resulting in a line topology. Also, they can employ star or tree topologies for more advanced configurations, although this is less common. Profinet, on the other hand, is based on standard Ethernet, the same Ethernet that you might have encountered in your home or office. Standard Ethernet cables are suitable for Profinet networks. However, most users employ Profinet cables, which are just Ethernet cables but ruggedized, built to withstand the rough environment of a factory. Just like with Profibus, in a Profinet network you have PLCs, PACs, and DCSs, and also sensors, actuators, robots, RFID readers, and other IOs. In Profinet, however, we call these controllers and devices, respectively. Similarly to Profibus, Profinet also allows users to save in wiring and installation costs by using distributed I/O mechanisms. Profinet users have more flexibility when designing a network. There's a variety of topology options: line, star, tree, and ring. Also, since Profinet networks are based on standard Ethernet, specialized switches are not required. You can utilize standard Ethernet switches to implement flexible topology options in a cost-effective manner. The only requirement for switches is 100 megabits per second full duplex. Profibus and Profinet are also different in other technical aspects. Profibus networks can achieve speeds of up to 12 megabits per second, although most run at 1.5 megabits per second. The telegram size can be up to 244 bytes, and the address space is limited to 126 devices per network. Profinet networks achieve speeds of 100 megabits per second or even 1 gigabits per second and higher. The telegram size can be up to 1440 bytes, and there are no limits on the address space. Another critical difference between Profibus and Profinet is the data exchange mechanism. Profibus employs a master-slave interaction, whereas Profinet uses a consumer-provider model. In a master-slave interaction, the master has unidirectional control over all its slave devices and processes. The controller will always be the master, and the I/O devices will always be slaves. The consumer-provider model is more flexible. In Profinet networks, controllers and I/O devices can both assume consumer and provider roles, leveraging the full duplex nature of Ethernet. The controller provides output data to the configured I/O devices in its role as provider and is the consumer of input data from I/O devices. The I/O device is the provider of input data and the consumer of output data. There are many substantial differences between Profibus and Profinet, yet Profibus and Profinet are both well-proven industry leaders. They are both suitable to fulfill complex automation requirements in discrete, process, hybrid, and motion control applications. Thousands of device manufacturers develop and produce products available with either a Profibus or Profinet interface. As of 2019, there were over 32 million Profinet nodes and 60 million Profibus nodes installed worldwide. It makes sense that Profibus is more prevalent. Profinet is the younger technology, and when it was introduced, there were already tens of millions of installed Profibus devices. Between the two, Profinet is the clear winner from a technical and investment protection perspective. Today, the adoption of Profinet is growing exponentially, and in some years, its adoption will surpass Profibus. But even then, Profibus will still be an industry leader, and it will continue being the leading serial field bus technology historically.
We've covered a lot of material in this video. If you'd like to have this content as a PDF to be saved for future reference, we've created a downloadable document for you. Just follow the link in our description to the Profibus versus Profinet white paper. Also, you can visit our website at us.profinet.com to learn more about the technologies through training opportunities, written materials, and much more. Please feel free to share your questions and feedback in the comments below, and thank you for watching.